Hi everyone. Once again, apologies for my voice. In this tutorial, we're going to look at approximating the sampling distribution for a sample proportion by using a normal distribution. You will remember when we were looking at the normal distribution, we learnt that if the sample size is large enough, the distribution of a binomial random variable is approximated by the normal distribution. We also learnt that when the values of n times p and n times 1 minus p are greater than 5, then we can use the normal distribution to approximate the probabilities in a binomial distribution. The same thing can happen in statistics and sampling. If the population in a question is sufficiently large, then we can use the normal distribution to approximate probabilities in a binomial distribution. And this approximation is done using the TI Inspire CAS calculator. Let's look at this problem to illustrate. Let's assume that 55% of people in Australia have blue eyes. We're going to use our calculator to illustrate a possible distribution of sample proportions, p hat, that may be obtained when 200 different samples, each of size 100, are selected from the population. With our calculator, we need to do three different things. The first thing we need to do is open a lists and spreadsheet page. We need to enter data into column A. We need to give it a title, and the title is Prob Blue, meaning the probability that somebody has blue eyes. We then need to set up the formula cell of column A. We need to start with an equal sign and then enter, go to menu, data, random, binomial, and enter these data statistics. We need to enter our sample size, the value of the population proportion, 0.55, the number of samples we're going to collect, and then divide the whole data set by 100. So we're going to go to our CAS calculator and do this. We go to Home and we select Lists and Spreadsheets. We set up column A, we give it a title, and we simply type in Prob Blue. We then go to the formula cell. We type in equals, and we're going to now go to menu, data, random, binomial. And now we're going to put in our statistics. The sample size is 100. The population proportion is 0.55. The number of samples we're going to collect is 200. And then we're going to divide all of these statistics by the sample size, 100. We hit enter and we get our distribution for our population proportion. Our sample proportion. So our second step now is to create a histogram. We need to go to the Data and Statistics page. We need to click to add our variable and we select Prob Blue. And then the dot plot is displayed. So now let's do the same thing on our CAS calculator. Go to Home, select a data and statistics page, and you'll see on here, here are all of our data points from our 200 samples. We click to add variable and we select Prob Blue, and our histogram is created. So now this is our third step. Once we've created our histogram, what we need to do, we need to go to Menu, Plot Type, Histogram, and then we need to go to Menu again, Analyze and Show Normal PDF. When we do this, we'll get a nice bell curve over our histogram, and at the top it will tell us what our mean is for our normal distribution and what our standard deviation is. So now we're going to do the same thing with our calculator. We'll go to Menu, we'll go to Plot Type, and we'll go to Histogram. So our dot plot then becomes a nice histogram, and we can see it. It's roughly normally distributed, but it's a little bit skewed. We go to Menu again, and we go to Analyze, and now we do Show Normal. So I go to Analyze, Show Normal PDF, and there it is. And if I move this up here, we can see that we have our bell curve on top of the histogram. Here is our mean for our normal distribution, 0.54965, and here is our standard deviation, 0.0487881. So what this is now showing is how for the problem that we're looking at, if I wanted to approximate that binomial distribution using the normal distribution, this is what the bell curve would look like, and this is the mean and standard deviation that I would use. So how can I apply this to a problem? First of all, remember that when the sample size n is large enough, the sample proportion p hat can be approximately normal, can be approximated using a normal distribution with a mean of p and a standard deviation of p times 1 minus p over n. So let's look at this problem now. Say we know that 60% of people have a driver's licence. We're going to use a normal approximation now to find the approximate probability that a randomly selected sample size, in a randomly selected size of 200, more than 65% of people have a driver's licence. In this problem, n is 200 and p, the population proportion, is 0.6. Since the sample size is large, we can approximate this distribution using a normal distribution. We're going to use a mean of 0.6, and we're going to use 0.6 to find the standard deviation. We're going to multiply 0.6 by 1 minus 0.6 and divide it by the sample size, 200. We get a standard deviation of 0.0346. So now, to find the probability that the sample proportion is going to be more than 0.65, we're going to find the probability that p hat is greater than 0.65 using a normal distribution. We find that our answer is 0.0745. So let's do the same thing with this problem. A car manufacturer expects 10% of cars produced to require minor adjustments before they are certified as ready for sale. What is the approximate probability that more than 15% of the next 200 cars inspected will require a minor adjustment? So it's an approximate probability, so I'm going to use a normal distribution. So in this problem, n is 200 and p is 0.1. This means that the mean I'm going to use is the same as the population proportion, which is 0.1, and the standard deviation is equal to p times 1 minus p over n, which is equal to 0.1 times 0.9 over 200. I find the square root and I get 0.0212. So now, using normal CDF, the probability that p hat is greater than 0.15, I'm going to enter these values into my normal CDF on my calculator. This is what it looks like. The lower bound is 0.15, the upper bound is infinity, the mean is 0.1 and the standard deviation is 0.0212. I click OK and here is my answer, 0.009175. I'm going to round that to 4 decimal places, so the probability that p hat is greater than 0.15 is approximately equal to 0.0092. So now, based on this tutorial and the examples that we've just done, I want you to do exercise 17C from page 706, and I want you to do questions 1 to 10. Thanks for watching.